Please welcome Ricardo, Brandon, Sidharth, Tomer, Jean-Louis, Alan, and Nikhil to the stage.
Well, welcome everyone. Thanks for being here. It's great to see so many faces. I think we were talking this entire day. We just wanted to get a couple of friends together, you know. Now it's all of you here. That's all. It's even better. We're going to be talking about frontier speech models, what it takes from here to get to experiences that feel indistinguishable from talking to a person. I am really excited to be joined by all these folks who are in the dungeons, like building amazing models for us. They're truly the experts in the space, and really excited to hear from them. I'll do a couple intros to get us started. I'm Nikhil. I'm the founder, CTO of Vapi. That's Brandon. He's the founder of Cartesia. They pioneered space models and one of the fastest latency TTS out there, and really high quality. Brandon, I don't know if you want to do a little Queen's, hello to everyone.
Hey, everyone.
That's Tomer. They are David AI, one of the leading labs that's providing data for all these models, and that's Sid. They're building full duplex models, training conversational AI, next generation of models called MetaVoice. Alan, maybe you guys know Hume. They pioneered expressive TTS through their special techniques in curating expressive data. They currently lead the way in speech-to-speech models, and we'll hear a lot more from them. Alan's flying in from New York, so thank you, Alan. That's Gene. Gene, they were the first people to take Whisper and productionize it for low latency systems. And right now, they have one of the best multilingual transcribers out there. They do a lot of model training, and also flying in from New York. Thank you, Gene. And then Ricardo. Ricardo is the CSO and one of the founding members from Speechmatics. Speechmatics, I'm sure you guys have seen, maybe there's a booth outside. They train amazing transcribers, amazing voices, and one of the leading providers for enterprises out there. They've been in the business for 11 years, and really curious to hear about their perspective on training as well. So I've kind of split up the panel into three big sections that I'm curious to touch on. We have, to starting us off, I want to talk about model architectures. Maybe even start off with what is the current model architectures out there, options out there, and then going towards future model architectures that we imagine, what are the pros and cons of them, getting into data challenges in scaling and training these models to be conversational, and ending towards curious to get funding and talk about how these audio labs are getting funding to scale and train these models going forward. We'll have time at the end for audience Q&A, so keep the thinking cap on, prepare some questions for us. Cool. Why don't we get started with the lay of the land currently. Brandon, do you want to talk about maybe what are current model architectures options out there? I'm sure most people know cascaded, but a lot of other people don't know about all the other options.
Yeah. I think can sort of give the lay of the land from the perspective of speech-to-speech conversational agents, which is the bulk of why people use Cartesia, and I think probably the bulk of the reason why people use Vapi.
Yeah.
I think I think the most common architecture and the one that people have been using to date is the cascaded architecture, right? So you have a speech-to-text system that takes the user speech, turns it into transcripts. The transcripts gets processed by an LLM. You can do function calling, background tool calling, other things in the LLM layer, and then sort of pass it to a text-to-speech system like Cartesia, which will sort of turn that into speech and then create a response for the user. I think my feeling is today the vast majority of production conversational agents are built this way. I think there's quite a few advantages. I think sort of the ability to sort of audit, use arbitrary business logic, sort of like have really high fidelity reasoning and reasoning, transcript following, guardrails, things like that is like sort of the big advantage. I think the sort of like main difficulties there have been like the bottleneck that happens because the information, the reasoning has to first pass through a text layer, and this makes it more difficult to do naturalness because you have to bring in a lot of external models to do emotion classification, also to do things like endpointing and turn detection, and I think just the orchestration of these things is quite complicated and can have sort of have high latency because each different tool incurs its own latency. So our role there is like we have a text-to-speech model. It's really fast, so it helps sort of bring down latency for the whole system. Other architectures here are like people are fusing the transcriber and the LLM together into like kind of a thinker architecture, right? This takes audio in and it outputs text out. This can be pretty nice because you still have the intermediary through text, able to use that layer for reasoning, compatible with good TTS systems, but maybe like makes things like endpointing and then other sort of end-to-end speech things like emotion detection and things like that can be built into the model directly, so it's easier. After that, I think you see sort of more of like the speech-to-speech model architectures. I think there's two. There's like half duplex, full duplex. In half duplex, you basically get the user turn as input and then sort of generate the output turn for the conversation directly in speech. This works pretty well, but I think like and you sort of get a lot of the emotionality and end-to-end training, but I think the big gap here is sort of like the ability to do like full duplex conversation where maybe like you want the agent to sort of back channel and like acknowledge what you're saying, the ability to do interruptions, things like that still have to be handled externally with like a VAD, right? And then obviously like the part where everyone's working towards is like a full duplex speech-to-speech model. I think actually I heard a few people finally have this working in production the other day, like 2 weeks ago, for sort of like more naturalness focused use cases like outbound phone calling, gaming, I think are like the two that I heard. But I think there you get really natural conversations because it can always be listening and always be talking, and so you can sort of make it speak like a human. I think today, right? I think like a lot of the reasoning and transcript following and other types of abilities are I think what's holding people back from like deploying it more widely. But I think things will get there, and it's cool to see that like I think for the first time 2 weeks ago, somebody told me they're actually trying one of these in production
working,
and having good results. So
maybe we'll play a quick clip or something. That'll be fun. I think I want to kind of hammer home, because it was hard for me to wrap my head around like half duplex versus full duplex. But OpenAI GPT real time would be half duplex, right? In this kind of description that you said, or
I actually haven't played around with it enough to know, but I guess you would know based on whether or not it can do things like interrupting you, back channeling during your conversation, things like that.
So like OpenAI's real time, the speech-to-speech that they're kind of the cutting edge, even that is like, to our best understanding, half duplex. And there's even a further frontier of full duplex, and maybe we'll get a bit into like what are the challenges there and like maybe why it's kind of hard. But beyond these four, I'm curious from anyone else, I guess any other things that you want to shout out maybe any other architectures? I know, Ellen, you do a bunch.
Yeah, I mean, half duplex is equivalent to full duplex unless you have two streams that actually need to be handled simultaneously, so like overlapping speech, right? But mathematically, you can make them equivalent otherwise. You could play around with different ways of handling overlapping speech as well. So yeah, actually that speaks to kind of maybe another kind of broader point is that you can separate model architecture from system architecture. I think a lot of the system, what Brandon was talking about system architecture-wise is, yes, you can have separate models for ASR, TTS, but they could all be models that are capable of speech-to-speech. Right?
Right.
Or you can have the full duplex model handling turn-taking decision-making, but then you can have a half duplex model handling response generation.
Interesting.
And there's a lot of different configurations besides, I think, having like the specific cascade of ASR, language, TTS.
Right, like you kind of fuse basically all permutations in whatever way you wanted. I think maybe it'll be good for first, before we get into the details and nitty-gritty of it, but this talk will be fairly technical. Maybe we should, if you do think there's like something that we're really going off of, maybe just raise a hand and we can clarify on the spot. Maybe you can help us everyone understand like what motivates even full duplex. I know Brandon set up a bit of ground there on like cascaded architectures just can't, like, there's information loss. And we also heard about this in the keynote today, so maybe you're all primed for it. But like, why does this not feel the final architecture to you of like voice AI? Maybe you want to give your take on it.
I mean, I think the where things are going is it's not all going to be one model handling everything. Because imagine you had like a 400 billion parameter reasoning model, and you had to rely on that to generate all of your speech tokens. There's ways of making that practical, but you might not want that. Like, it might be too expensive. You might have to do too much to preserve the language capability. And so you probably want a model, but on the other hand, you do want a model that understands language to generate speech. Right? If it doesn't understand what it's saying, it's not going to be able to emphasize the right words and like know what kind of emotions the speaker might be feeling or should be conveying with a given expression. So you want a model you want basically a bunch of models that understand language and speech, in my opinion.
So do you imagine the final architecture, kind of for audience benefit, is like you have a model that takes in speech, it's in the embedding space in the middle, and there's like some portion of text or some embeddings or text go out to like a longer reasoning model. Meanwhile, the longer reasoning model can maybe feed some embedding back into this architecture, but also like maybe straight through the embeddings just pass through and like start saying something. Is that kind of what you imagine, like in the final form of this?
Yeah, I think that is one way of implementing it, is to have a model that is explicitly speech to speech, whether it's half duplex or full duplex. Like I said, it might not matter, but have that be the model that generates your immediate responses, has the final role in deciding if the user's done speaking and whether there should be a response, does back channeling, but doesn't do like the reasoning part. But it is smart enough to be able to generate the best possible response that could be generated at low latency, so 200 millisecond conversational latency. It's
kind of complex, no? Like the information flow in the architecture. I'm curious, like, what are other takes on like the final form of like voice AI architectures, or what do you guys think is the frontier because each of you guys are trying to build the future voice models, right? I'm sure in your own capacity. Like, how do you think about like the future architectures? Maybe Gene, you wanna?
Yeah. On my side, I think I pretty agree that it's going to be hybrid. If you think about a call centers, for instance, you want to have good greetings, you want to have like a good experience, good emotions as you're working on. You want to have a good brain relationship, and once you get into the details about your billing, about your customer information, about updating, like tracking your package, etc. It's not a question of like the emotion and the relationship you have with the brand. It's more a question like the exact, I would say, information that goes from the customers to the system and from the system to the customers. And it's not time for like relationship and emotion. It's time for like perfection, kind of. And as you stated, you can have models that can do everything, but the cost will be insane. And considering that you want to have like this being deployed everywhere, you can't like have all these costs. And there was a paper from Google that showed that people have a better satisfaction when they see that you have expertise in your voice agents. So you have greetings, then I'm going to tell you, what's your problem? You're going to tell me it's about billing. And even if it's the same model, you're going to say, okay, I'm going to pass you to the agent that is specialized in billing. You change the voice, and they prove that the satisfaction will be better, even if the result is exactly the same. Just changing the voice gives you a sense as a human that you've been taken seriously into someone that has the expertise.
Right.
And so I think it's going to be the same in the workflows. There are going to be moments when you want to have emotion connections. There are going to be some moments when you want to have expertise. And it's the same on your side. If you think about your brain, sometimes I'm going to talk with you. It's going to be a gentle cocktail or whatever. And sometimes you're going to give me like your phone number, address, or email, or whatever. I'm going to say, wait a minute. I'm going to take notes, and I'm going to take my pen, my paper, and I'm going to slow down and write the notes. And you are doing the same things in your brain. Sometimes you're social. Sometimes you're kind of scientific and technical. So I believe it's going to be a place for collaboration.
Interesting. I know you guys,
Yeah, I mean, we've definitely seen where people have sort of wanted to start off a conversation with a speech-to-speech model, then move on to a cascaded model, just because once you go into sort of the enterprise place, like that text at this point in time is so valuable for just making sure you've got the right guardrails, making sure that things are pushed across. But when we come to think about the training, sort of ultimately, we do want to let these models learn, and eventually they will get the ability to do more and more, and the cost will come within the right bracket.
Yeah.
But like the way I think about it at the moment is, I don't necessarily, even if I'm training an agent that I want to sort of perform like a business purpose, but also you could also be training this to, I don't know, be like your robot girlfriend.
Yeah.
Like, I don't necessarily want the same qualities from my coworker and my girlfriend at this point in time, right? So maybe some people do, but sort of what we you do want to be able to specialize for what that output is, and I think the whole passing off to another model is a really effective way of doing
Interesting. I think, Sid, you want to pull up a recording or something? Maybe it'd be good for people to understand like what full duplex and backchanneling means. Maybe if you want to.
Yeah, I just want to add a point before I can pull out the recording, if you guys want to hear it. It's just a proof of concept of our duplex model. So for me, it's about like what is the best conversation experience? What really embodies a human behavior for conversations? And that to me has two characteristics. A, it can listen and speak at the same time. So you can manage all these like rich nuances like interruptions, overlaps, interjecting me to correct me if I'm getting an information wrong. And that happens a lot, like mostly 50% of the times you're back channeling to let the person know you're listening. And then the other aspect is speech to speech, where you're able to just straight away understand the tone, emotion, and context. And what's holding the space back right now is the ability to reference the right, I would say, workflow or intelligence for that scenario in mind. Maybe asynchronously, maybe synchronously, I'm not sure. You might pass it on to a different agent, but it will still be duplex speech to speech. And so I think that really comes down to system construction or for the workflow construction. But to me, the future has to be this way because otherwise there's just too much fatigue. Beyond 2 minutes, the illusion breaks, you're really frustrated, you can't speak as you would with another human, and you'll find yourself just like cutting it. And right now, where I personally see most adoption successfully happen is in these transactional workflows in business settings, where you couldn't get to resolving your scenario previously. And so these systems have helped with that. And as a result, people are okay to let go of some of the friction points right now in favor of just getting the task done. But if we believe that the future is fully agentic, and agentic in the digital space and the physical space, it has to feel human. That's the minimum threshold here. So I'll pull out a recording.
Yeah, you can pull a recording. Alan, I want to understand a bit more of like, it's also really funny, like we have the enterprise side. We need it's like, clear like you need cascaded systems for like the reliability. But also like, I don't know, the kid in me is like, the full duplex is so freaking cool, where you just talk to this and it layers on. Because even if you're noticing, like when we are changing turns, it's like layer on, you back channel. There's so much stuff. So I had a question around that. Where Alan, you said like half full duplex and half duplex are very similar. But in my mind, I was trying to understand like how that's feasible. Where right now, when models are given context, right? They're given context of like system prompt, user prompt, assistant, user assistant, and these are all very long turns. And the model internally obviously can understand and learns how to pay attention to the user. Like it's like, if I want to know what the user said, it's like all there right next to each other. In a full duplex, if you have like, you're layering on the context and like every 20 milliseconds there's like user audio, user assistant, user assistant, user assistant. For a model to learn like what to piece together what the user is saying, it feels like a completely different internal model. So how do you think about like, what is the model, like why to you is like half duplex and full duplex very similar? And maybe you can help us train our intuition around this.
Yeah, I think the distinction you're getting at there is between like how you interleave the tokens. So you could really interleave the speech tokens and word text tokens like very densely, or you can interleave them loosely, and both of those can be compatible with either half duplex or full duplex.
In the full duplex, like in full duplex, you won't be able to interleave them separately because the assistant is constantly speaking, even if it's emitting silence. So you have to interleave them. No?
I'm not sure what you mean. Yeah, I mean you have to interleave them if you want the user turn to be put in the middle of an assistant turn?
Yeah, exactly. It's like as I'm speaking, right now as I'm speaking,
but
you're emitting silence tokens, they're emitting in the tokens in the middle, we're overlapping on each other, and that is all interleaved, right?
If there's overlap, then yes, but otherwise you could just interleave you can put in my parts, and then you can put in your parts, right?
You can put in your,
and right. You can just break it at any time, right?
What about, I guess, back channels and like, you just interleave them as well? Interesting.
Yeah. Things can just be actually temporarily unfolding.
Sid, I know you guys have been running experiments on like what tokenized packing works better, and what have you seen work? Like, can in full duplex you separate out the token space and like?
Separate out in what?
Like how do you usually try to pack the context for the models in full duplex? Like what different techniques have you guys tried?
Yeah, what's working really well for us right now is finding a good frame size where you can just give it some information so that it simulates behavior of listening and speaking at the same time. For us, anywhere between, I would say, 200 to 300 milliseconds worth of frame context is enough. And that gives you this really good conversational flow. It also allows the modal inference speed to also be fast enough with human turn-taking capabilities. And so that's working well now. Whether that will be the case and we'll still keep it with the mature product or not, we're not sure. So we'll see.
I don't know if the recording you'll be able to pull through.
We can try it.
See if you put it in the speaker.
This is an onboarding demo we built for a potential client.
Hi, this is Mia. I'm here to onboard you onto Ash.
Put it close, yeah.
Hi there. I've just got a few brief questions. First off, what is your age?
I'm just north of 30.
Okay, great. And what do you do for work?
I work at an early stage startup. I'm a software developer. I write code.
Oh, incredible. And do you have a family?
Yeah, I've got a partner. No kids.
Okay. And what are you hoping to get at?
I've got a bit of anxiety, and I just need help with that.
I see. And are there any specific issues that you'd like me to?
Yeah, just, every time there's a deadline, it makes me panic, and it's an early stage startup, and there's a deadline every day, and we just feel like we're rushing from one thing to the other, and, I just stay awake all night in panic of, like, are we going to meet the deadline or not, and I struggle to sleep, and, it's just, I've not been sleeping much, and it's pretty horrible.
I see. I understand. Well, thank you so much for sharing all of this with me. And I've got
there we go.
So, I guess those portions to me around when it's she's layering on slowly the speech up, I see, or is she even back channels? For you, how do you think about, I guess maybe open it, your speech to these models, fitting that into the architecture?
So the exciting thing about this approach is because the architecture models or embodies human conversation styles, then it's about getting it the right data. And everything is just learned by giving it the right data curriculum. So enough, I would say, coverage over back channels, interruptions, overlaps, empathy where appropriate, etc. And so we didn't necessarily have to teach it these behaviors.
Interesting. Brandon, what about you guys? From your experiments into speech-to-speech, what have you learned, or what are challenges? Yeah.
I do think one of the big challenges for speech-to-speech is the data. Yes. I think that's I do think that's a very, very surprisingly large part of it. Maybe not surprising.
That's where Tomer comes in.
Yeah, exactly. So I think that's been big. I think architecture-wise, there's quite a few that work. I mean, you can do multi-stream models, you can interleave the models, you can use a big frame size. I think obviously we've been really excited about some of our research in state space models and dynamic tokenization as an approach for real multimodal duplex models. But I would say the modeling capability and maintaining the reasoning from the base LM.
Text
I think not having the model become dumb when you train it to be a speech-to-speech model, I think is a big outstanding, I think, research question, which is how do you really integrate and reason with speech, but get the same sort of reasoning, recall, and other capabilities you get in text.
What's your take? What's your mental model here? Is it an incremental model that the model is just not connecting the embedding spaces correctly? Or is your mental model that actually audio is kind of destroying the LLM intelligence a little bit because it's learning, again, how to see the world a little differently than...
Yeah, I think my mental model is that putting audio as the input doesn't really sacrifice much in terms of text reasoning, but trying to output an audio is what sacrifices a lot of reasoning capability.
Interesting.
I don't think there's any sort of published research on that, but I think that's fairly well known to people who train these models, I would say.
Yeah, I would tend to agree so as well.
So I would say there's that. And then I would say the other big challenge, again, is naturalness. I think that's a big data problem, but also good reward models for naturalness that aren't very subject to reward hacking, I think are still open problem. I don't know. If someone solved it, please let me know. I'll buy it.
That's a good segue into Tomer. Yeah, data.
I think that it's solved.
You think it's solved?
Yeah. I think at least the first problem is solved, yeah.
Which one? The reasoning problem?
Preserving language capability in a speech-language model.
In a speech-language model that generates text.
And speech.
And speech.
Yeah.
Interesting.
And when you say language capability, maybe you can help the audience catch up. Like, what did you mean by that? Like, what is preserved?
Everything, so, I mean, ideally you would update the language to actually reflect input speech patterns. But you could also just completely freeze the language capability so it does exactly what it would do with the same transcript and same text output, but now you're just adding speech tokens.
Oh, interesting. Got it. But I guess, like, how does the model learn how to connect? Like, again, I say a zip code 94112. Like, connect that into like text reasoning. If you freeze it completely, you don't see a loss there.
I mean, it can transcribe it and then,
right.
And then interleave the text tokens in. Yeah.
Okay. I do what you mean. Yes. Yeah. Fair. I guess that's one way to do it. Yeah. Tomer, maybe you want to give us a bit of tour of like data challenges, and maybe just for the context. I think the thing I'm personally very curious about is like if you look at coding, the most popular application right now, it's fairly well understood how to like scale data for it. You just like have millions of virtual machines, like give it a task of like do this Linux thing, and like it will output like a big chain, and then see which chain works, and like send that signal back. Like tell us a bit about like the lay of the land on audio data, and what are the challenges, and how are you solving them?
Yeah, so I can talk about what makes like audio different from the data context.
Yeah.
I think there's a few things. One is, you're kind of alluding to it. Audio is tough to verify. Like, what makes good audio is not obvious in the same way that it is in like code and math, where there's an objective right answer. Like, audio is subjective, and it's also very like dependent on the context. Like, what good looks like in a customer support conversation is very different than in gaming or with your like assistant that's meant to be a friend. I think that's one. I think two, audio has way more degrees of freedom. So, text on a page is kind of just like text on a page. Like, you can have more formal text, more casual text, but like directionally, it's pretty uniform. In audio, it's the opposite, where you can have different emotions and tones and pace and cadence, also like formality. And that creates a challenge on the data side, which I can get to in a sec. And then I think the last thing that to us really stands out in audio is the importance of multilinguality.
Yeah.
Like, obviously, that matters too in text, but in text you have pretty good language translation, and you don't need to account for all the different dialects and accents. Written Spanish is generally written Spanish, but when you speak it, there's like all these nuances. So I think those are the three things that we think about as like what makes audio like uniquely hard from a data standpoint. And for us, they all kind of map back to like one thing being really important in audio data, which is diversity of the data. Like across those 3 points, like you need conversations that span the like infinite kinds of interactions you can have with an audio model. You also need audio that accounts for all the different degrees of freedom that will occur, right? Like acoustic environments, emotions, like all these things we're referring to. And then obviously language too. So like going down the language, dialect, accent tree is really important. And that's like something that we're very focused on.
I guess maybe for everyone's intuition here, I think we saw Sora 2 came out yesterday, right? Like it seems like, and there's Nano Banana. So it seems like in space of image, people have cracked like using internet data and to get high consistency. Like, why is that not solved in audio? Like, why is it feels like a artisanal activity and a bespoke activity? Yeah.
Yeah, I think from our perspective, especially because we've been talking about these speech-to-speech, half duplex, full duplex models. Like, I think audio model architectures are more sensitive to the format of the data. So you have a ton of data on YouTube, but none of it is channel separated, which makes it hard to use for these like speech in, speech out systems. Also, again, like I think relative to how many degrees of freedom there are in audio, there's not that much data out there. And I think diversity is important, like I alluded to, but also like controlled diversity, where you understand what is going on in this audio. That becomes really important when you're trying to build like kind of context aware, like kind of appropriate responses in your audio model.
Interesting. And how do you think about like maybe this scaling? I know, Alan, we were talking a bit about like scaling through RL, where you auto-label data, but like, what are some techniques that maybe you can shed light on? Like, how are you thinking about scaling data to like thousands and millions and hundreds of millions of hours? Yeah.
Yeah, I mean, on the pre-training side, I think that what makes it more difficult to deal with audio is the fact that source separation is unsolved. So you'll notice, like with Sora, the audio quality is a little bit off. If you're like an audiophile, it's because it sounds like it's denoised. It sounds like you've put something through a denoiser, and then you've added in like other things on top, like other background effects.
Interesting.
And yeah, that is probably unsolved at the pre-training level still. But it is. But you know, we work a lot on the post-training level to bring back the audio quality, bring back the voice quality, which is why we're able to still get that at scale.
Yeah. And I know you guys started with like, we're going to have a lot of audio model, like voice actors, and collect really high quality data. But like since then, you have scaled that, right? Through our
we don't. So if you go on our platform, you can create voices with voice design or voice cloning with like 30 seconds of audio. And we explicitly tried not to have to rely on preset voices that are trained on like hundreds of hours of audio. Because you know, everybody wants their own voice, their own personality. Even if it's as simple as a customer service application, like you're going to want a different voice for your funeral home customer service versus like your amusement park customer service, etc. Like totally different voices and personalities because the user is in a completely different place when they call. So everyone needs to be able to customize that, and only the enterprise that's deploying it knows what kind of voice they need. So relying on presets is not great. But relying with end-to-end models on fine-tuning for each voice is also very hard for reasons of like difficult deployment. So it's very important to get zero shot right. And that's what we really focused on.
Yeah, makes sense. I want to open it up to audience questions. Yeah, go for it, right there.
JobTalk.ai.
Do we have like a mic that we're sending around, or just speak loudly? And I can repeat the question too, so that's not a problem.
Okay, my name is Taj. I'm from JobTalk.ai. We are a voice agent for recruiting. My current problem is that none of the models will recognize the answering machine. My future problem is that what if the other side the person is answering is a voice agent also?
Right. What problem do you have with the second one?
I just want to speak to the human because I'm a recruiter. I need to speak to a human to qualify the candidate.
Yes.
What if the other side isn't a voice agent?
Instead
of a person.
I don't know if maybe Tomer, you want to take data from data side. Like, are we going to classify voice agents, and like, is it going to be ever feasible?
Yeah, I guess it's an interesting problem. Like, we're mostly focused on generating data between two people, so the model knows how to interact with another person. But you can also think about collecting data sets between a human and a model, and teaching the human how to kind of, the human that you plan to train the model side on how to interact with like a system when, a system might be a little bit different. Maybe in the future they converge though, if the models are so natural that it's all the same.
Is anybody working on this problem?
I mean, I'd say that as at the moment, sort of like in terms of just like recognizing audio events, that's something you could, so like the answering machine, that's something that's definitely able to do very easily. And you started off with things like applause and laughter, and actually recognizing those audio sounds is something that's definitely doable nowadays. On the second part of it, the interesting thing is that text-to-speech transcribes really well. And so it's almost a case where sort of if you are getting sort of an agent talking to agent, sort of the transcription, the quality of the conversation is going to be so good that you're almost going to begin to know that it's fake. I don't know what the answer is for that. I mean, obviously, the number of LLMs that are now talking to LLMs anyway, sort of there is just madness therein lies. I don't really have a solution for you, unfortunately.
Thank you.
There are some tricks to knowing if it's human or not automatically. If you can like probe it. If you want to work on that, you can reach out. Yeah, we have.
Okay, I think I want to move to the next question. Yes.
Yeah, I had a question. You said you were focused a lot on zero shot cloning. One of the things we talked about in this panel is how many degrees of freedom there exists in audio. Certainly, somebody's voice and personality settings that come from. How do you achieve that? You think at Hume with just 10 to 15 seconds of audio with any sort of.
Let me repeat the question for the recording benefit. The question was, we talked a lot about cloning. How is it feasible to get from 10 seconds really rich audio understanding and cloned voices?
Yeah, I mean, so it's about shifting the problem to the right data set. Basically, if you're relying on fine-tuning on many hours of actor data, your model is probably not going to be able to generalize outside of what's in that data as far as expressivity. So if if the person's tired and they sound tired, you're not going to get the model to not sound tired anymore. I mean, that's an extreme example, but for us, we shifted the problem of understanding prosody, understanding expression to pre-training, and try to understand like the whole world of all expressions and voices at the same time. And we don't disassociate expressivity or phonetics from voice. And that's really important to be able to get the model to understand for a new voice, what would it sound like if it were in a different situation, a different acoustic environment, a different kind of conversation than it is in this particular data. And then you just go, and then you gradually diminish how much data you need for every new voice until it's like basically thin slicing. Like a human can take a 20-second sample of audio and really understand and infer a lot more of what that speaker sounds like from that 20 seconds. And that's
is it the magic number, like 20 seconds, you just get everything that you want?
Actually, that really depends. So like if it's a really rich 20 seconds, yes. But if it's not, then then it might not be enough. So you need the right combination of signals to be within those 20 seconds.
I know, Brandon, you guys are also do like very quick voice cloning. I don't know if you want to add something.
I think we have pretty good voice cloning. You should try it out yourself and let us know. I think there's like a couple things to this. I would say like for us, it's like minimum 3 seconds, but typically with 3 seconds, you get a lot of information about like timbre, about tone, maybe about pacing, right? With like 20 seconds, depending on the words that are said, if you say, there are certain sentences that have every single phone in the English language, would probably also work if trained out well enough, but I think it's tough, right? And I think there are some things where, you really understand patterns when you have hours of data, like how do people ask questions, how do people, how do people enunciate in specific situations, like maybe the way I read out phone numbers is like I like to slow down, right? That's like very difficult to zero-shot extrapolate from 20 seconds because you don't have the full sort of information. So for us, we have like two types, right? One is instant cloning, which 3 to 20 seconds. One is like sort of professional voice clones where you can actually fine-tune the model to do that. That's sort of how you might capture some of these like more long-range nuances of voice. But I think like there's a separate question which I think Alan alluded to, which is like zero-shot voice cloning. I think you can learn it end-to-end. I think there's a separate thing that's harder, which is like, can you do voice cloning but also create new levels of controllability, right? Like, I gave you a noisy, like one we get a lot is like, I gave you a noisy clone, the output is still noisy. Why is that? And it's like, some people actually want it to be noisy. Like I know Nikhil yelled at me once because he was like, our customers want it to sound like they're in a call center with like background noise and like grainy, right? And then like other people will yell at me and be like, our customers only want like the crispest studio sounding audio ever, right? And like how do you sort of like take one clip and offer all these different types of control over accent, over like multilingual, right? Like how do I extrapolate what it sounds like when Nikhil speaks, I don't know, in German. Like, right, that's like a zero-shot extrapolation. The model can do that, but like if you want like fine-grained control over every aspect, I think that's sort of like the research frontier on the zero-shot cloning side, and I think what we've been working on.
Yeah, go for it. The question is around consistency across sessions. When can we expect TTS models to be consistent in speed and tonality across sessions? The timeline for that. The TTS people go for it.
I think it's solved for a lot of cases, but
I know specifically they are interested in UK voice, like accent.
Yeah, I mean, it depends on your bar, right? Your bar is probably really high. if you want, you could do a fine tune of the speech LLM, and then you'll get complete consistency for a voice. But that's a little bit expensive. So.
The other challenge also here is context. Like if you're just synthesizing plain text into speech, it doesn't have context over the conversation as to how it's unrolled, and that really matters. Right? If your conversation started really enthusiastic, but you've lost that context, and now suddenly it dips in enthusiasm, you'll start to feel that it's changing and not consistent as you want it. So I think that contextual understanding really matters, which is where some of our work also will eventually come and shine. But I think you kind of want, if something immediate, a contextual text-to-speech system.
I'll take it from the back, yeah. I think the question is still around like real-time voice cloning. Like, should we expect next frontiers of it? Like, is there anything coming up, like from your guys' research, or?
Is there a feature you have in mind?
Yeah, I was going to ask the same.
I think more context, like just like, if I understood the question. Informative, yeah. Like basically, like real-time understanding. Like it should, when it talks to me, can it like know me and like. You talk to me differently than you talk to Alan. Like, will that adaptiveness? I guess like that maybe goes into what you were saying. Like it has to be speech-to-speech models. Yeah.
You need that context of both the present conversation, but the past to understand. Okay, how it has unrolled over a period of time.
Yeah.
And I think this is where current systems are lacking. And that's the gap that we want to address.
I think we'll probably take one more question. Do we want some gender diversity, maybe? I don't know. No one else has anything? National diversity? Go for it, sure.
The question is, for those of us building for enterprise, actually building the prompts, building the agents, testing them, and then iterating. When these next frontier models, half duplex, full duplex, come out, what changes for us? Because we want to bring those beautiful games to all of our customers.
Yeah.
How much of a lapse between, how does all the prompting change? How long does it take you guys to implement, do your beautiful orchestration work? What does that look? What does it look like at the deployment level once we figure out proper duplex?
Yeah. The question was, once there is like duplex models out there, like how long will the dispersion of them take? Maybe Sid, you want to answer?
Yeah, I'd love to work with you to figure this out. But look, our aim is to avoid orchestration entirely. We want to make sure that conversation get given to you out of the box fully, so that you focus on the workflow, you focus on providing the instruction and the right context. And so as much as possible, I would love to ensure your prompts stay as is, and we just like are able to adapt to that prompt instead. And then we give you the right control levers, both in terms of the content that the AI will say, but also the behavior of the personality, both from its tone to its emotions to its behavior over time, and make the overall experience much easier. And then also, work with design partners to find the right guardrails to ensure that, it doesn't really negatively impact privacy or security in any way.
Maybe also just say one thing, which is a lot of these things, the way we see, I guess, especially enterprise or bigger companies' role is like A/B testing. So you can make the agent, again, Vapi or whatever platform you're using, and like you'll make one GPT real-time agent and like put that in a head-to-head, and over time, this is how it slowly things change, things move.
I'll just add one more point. We've also found that right now using secondary systems as a way to double-check what's happening in the early stages has been good. It can step in and then avoid, something going off rails. So yeah, that's an intermediate workaround.
Yeah. Anyone else? Mamata, go for it. I think the question is around like structured data. I'm sure you guys get this a lot. Phone numbers, addresses. When is that going to get fixed, bro?
Is this? is this transcribing phone numbers or
no, speaking?
Yeah, it's speaking phone numbers. Yeah, I mean, we do get this one a lot. I think it's like a surprising sort of like how challenging it is. I would say like there's been a lot of progress actually over the last 6 months to a year, at least for our models, where I think like 6 months to a year ago, I would say like there was transcript following difficulties with a lot of TTS models, ours included, where like you would have it speak a phone number and it might like get one of the numbers wrong, which is terrible. I think that's largely been solved. Like I think our models like almost never hallucinate on phone numbers or spelling these days. And I think like, but I think like now the new frontier is like naturalness, which is like, sometimes it rushes through the phone numbers. I think people want it to slow down. They want it to enunciate. Well, we have a new model release where I think that was a big priority for us. And so, hopefully some progress there soon. But I do think like, now that a lot of the fundamental transcript following issues are resolved, I think like the opportunity to sort of like get it to sound more natural, I think has moved more towards a data problem. And so I think you should expect to see like fast progress.
Coming soon.
From the speech to text perspective as well, there's it's definitely a problem across the board. We've got a nice chunk of work. It's like 3 months. It's just titled alphanumerics internally, which is how we want to get these running correctly. It is a really big challenge. That I mean, we spent a long time. So this is a while ago, but like inverse text normalizing everything in our top sort of 25 languages just to sort of try and solve that problem. And it got us to a certain point, but now it's got to the point again where actually it's like a rehash, try and like rebuild the models from scratch to try and do it, because it is a nasty one, and no one's got it perfect, but it is certainly moving in the right direction. But
I know we only have 2.5 left. I want to give to maybe one last word for each panelist. Maybe just we'll go around, like, what do you hope, like, what's one thing you want everyone to take away? And again, to remind everyone, like, I hope everyone kind of takes away their intuition on, like, when can we expect, like, frontiers, like model improvement, more natural, like voice AI, and hopefully, like, some of the technical understanding helps inform what you guys do in building applications. But maybe we can go around and just like say one word. You want to start, Brandon? Go for it.
Yeah, I mean, no, I think it's been great. Also super insightful. Thank you for all the great questions. I would say like, for us, I think we started with sort of pushing the boundaries of text-to-speech and latency. And I think, moving more and more into end-to-end voice models. I would say like, what I'm really excited about is like, we've always been really excited about building the best text-to-speech for voice agents and businesses. We want to build the best speech-to-speech models for voice agents and businesses. And I think for us, we think that there's still so much room, both in like the controllability and quality and voice quality side, but also in the sort of like reliability, transcript following, and reasoning side. And yeah, we're super excited to sort of work with folks like you to sort of push the boundaries together.
Maybe I'll change the question to be more precise. When do you expect to talk to a phone or a laptop and you can't tell it's a person or can't tell it's an AI?
I think that happens sometimes already. I remember one time you told me like, there was a phone call that was like 3 hours long, and so I think it happens occasionally already. I don't think it happens in general, unfortunately, because there are places where current speech models fall down when it comes to phone numbers or other things like that. I expect it to be more of like a continuum rather than like a boundary. But I think the types of things that I think will help us get there are like better contextual understanding. Maybe like more like speech-to-speech models or partial speech-to-speech models. And then also I think definitely a lot of work sort of like understanding the use cases, understanding the data. Cool. But I think it happens a little bit already, I think. Yeah.
Ear, we'll rush through it. Tomer, any ear guidance?
Yeah. I think I agree with what Brandon was saying. I think in like a generic English use case, and maybe that's occasionally achieved, but I think slowly it's going to have to push to the long tails and the margins, different languages, different use cases, and that's going to take a really long time. It's going to be a continuous process.
Yeah, my take is that in consumer applications, you'll start to see this get adopted much faster, especially over the English languages where data is more abundant and readily available. In more complex scenarios, for example, debt collection, where there's a lot of like guardrails that need to be introduced and also like compliance that needs to be resolved, I think over there adoption is going to be slower. So yeah, I expect to see like consumer have the biggest uptake soon.
2026?
Yeah, 2026, let's do it.
Alan?
Yeah, I mean, things are moving extremely fast. I would definitely encourage people who are interested or using voice AI to just keep trying the different models from the different providers. get a sense of, where's the progress, be open to obviously build an architecture that is flexible so you can always use the right provider. These are always good decisions. And we just launched a model yesterday that is very good at phone numbers, for example. Yeah. So, and very good at many languages, like big leap forward for Japanese and some other ones.
It's faster and cheaper, I think.
Faster and cheaper, yeah. So like things are changing very, very fast. I would just, keep trying things. And I think at some point next year, we'll be at the stage where it sounds indiscriminable from a human, but like we won't be able to identify exactly when that happens because it's just a gradual transition.
Yeah, totally. Anything to add, Gene?
I'm glad you're putting the model thing. We're just releasing a model today, so it's the fastest and the best, of course, like everyone. So I have two comments there. I think the first trap that can happen is like not having your own eval set, and I think that's the one thing I recommend everyone. As you said, things are moving fast. You need to have a good evaluation set that is for your use case. That's a big trap that people fall into. And I'm seeing many people starting companies there. And I think the second trap, it's more founder to founder type of like advice is being extremely focused. Don't be too generalist. You tend to think that if we do more, then it's better. And that's not the truth. You are staffing AI thing. That's one of the most successful startups I've seen so far. Like people doing like staffing automation, people doing like debt collections, etc., and not being too generalist, but focusing on one problem, doing it well, having a good eval set on this, and finding the best model to solve your problem. You're going to make like money extremely fast, and you're going to be extremely successful. And that's more like a founder-to-founder type of like advice. Be very careful because you can get lost with all the innovations, and we can do more, etc., etc. Of course, we are talking about frontiers things. You can fall into a trap when trying too many new things gets you lost at some point. So
thanks for the words of wisdom.
I didn't know they've released a new model, but R1 will definitely be faster, cheaper, and more. No, in all seriousness, I totally agree with the evaluation thing. It's really important to make sure you know what works and what doesn't. My view is probably be slightly different. I'd say that the number of audio that's going to be recorded and transcribed and generated over the next couple of years is going to be sort of 10xing and more, and there is a huge amount of opportunity to make a lot of money there. I think speech-to-speech models are really exciting, but I don't think they're going to be driving the majority of that in 2026.
Economic, yeah.
I think it is going to continue to be sort of a cascaded/hybrid type approach. But I actually think the thing that matters more is like if you really want to be successful, I'd say like make these models easy to integrate, easy to use, like that really focus on that sort of interoperability with everything else. Because if you get that right, then honestly the rest of it is easy.
I just heard a recommendation for Vapi from everyone. Well, thank you all to our panelists. We should give them a round of applause. They're around if you want to bug them. And thanks again for flying in. Let's get off the stage so the next panel will come in.
Thanks.